Good afternoon, everybody. Back by popular demand. Today is actually a two-parter from last month's storm and sanitary and pipe design. I am Carl. I'm your senior civil technical specialist at ATG USA. You can come check us out anytime for any of your training needs. You might get me, you might get somebody even more fun, but that's kind of hard to beat. Last month, we went over pipe network creation tools in Civil 3D, how to create pipe networks from objects, setting up pipe rules, some layer settings in that one as well. We went over the fantastic CTC tools and Project Explorer on how to manipulate our pipe information. We went through and analyzed the gravity network in Civil 3D, which was a new function added. Showed you a little bit about the part mapper and how that's going to come into play today as we export out all of our Civil 3D information into storm sewers and hydrographs. And also went through a little bit with the part catalog modifications and how to create some custom labels. So don't forget to go back and check that one out. Remember, this is a two-parter. So today we're going to be going over, we're going to prepare some of those Civil 3D pipe networks, catchments, and use some stage storage to get some information. We're going to import those Civil 3D pipe networks and background information. We're going to get some information for some of those hydraulic imports, i.e. our C values and CNs and soil types and IDF curve information, and everywhere where you can get that. We're going to utilize some good government websites for that. That's what your taxpayers are for. We're going to analyze that storm network, and we're going to be doing that with the rational method. And we're going to analyze that pond 2. And I'm actually going to do that in rational, but I'll also show you how to do that with SCS real quick. And then we're going to generate those reports, and we're going to put those into a drainage report there at the end. We're going to hand that over, and we're going to be done with that project. Till next time, we can do some other things. All right, so let's get wet. I am so sorry about that, guys. Here, let's go back and we're gonna act like none of that happened. All right, so well, you didn't really miss much. I just turned on my existing ground surface and opened up my Civil 3D, my sim tools, and I'm double checking my pond here. And let's go ahead and start with that functionality. And I need to check and make sure. Let's see here. What elevation do we have here? That's going to be at coordinates off. Oh, it's going to be at 20. So let's see what we got here. Pipe point. Let's go to pipe designer. Threw me off my groove there. Wrong one. That's okay. It's a lovely Thursday afternoon. Sun's out. New year, new me. All right. So I've selected my downstream and upstream pipe. I'm running through my pipe planner here, and it looks like my invert actually needs to be at 20 where my outfall is, but in reality, I probably need to bring that down to 18 because I don't have my maximum cover there. So let's, or I don't have my minimum cover. That's problematic. Let's go to, we're going to match my inverts, and I'm going to go to edit those elevations, and I actually want this invert to be at 18. I'm going to now run this to go back to elevations here, and I'm going to just change that to 1950. And then I'm going to interpolate the slopes between those two. 0.30. We're hanging out in Mississippi for this job at the Gulf, so I can actually run it that thin. So I'm going to go ahead and do that. Right click here and apply. Let's lock that stump at 0. Alrighty. So with that taken care of, I'm just going to hit apply. And that's saying my minimum cover is violated because it's outfalling into my pond, and that is fine. All right, so we're going to come over to here. And now that that's taken care of, I'm just going to offset this. I believe this is at a 3:1, 18, and do a quick elevation edit on it. And actually move this little guy. All right, see, there we go, 18. All right, and I'm going to go over here and just add that to my surface while I'm edit. Actually, I need to do that in my main finished drawing there, so we're going to check that out. All right, so all of our pipes, we've got actually this network comes out, flows into here. This road section flows into here, and this is our outfall. It's tying into an existing pipe network downstream here. So we want to keep that in mind as we're going through here. And I'm just going to go ahead and close out that one and add that one to my pond information. Now that all that's taken care of, go back over to here where I've got my pond surface, polyline, offset 3. Now, if I was really good, I would have done that with a grading object, but that's for a different class and a different time. So I'm just going to do that. Go up here to my properties and add that into, let's go ahead and take that out of there. So now that we've gone through all of that, we've got to go through and get some information for us to actually, let's find out where pond A is. Pond A, there we go. Just gonna add it to that break line and change that mid towards distance. Select that one. There we go. Now I've got a great pond there. All right. Hopefully everyone had an outstanding Christmas and New Year's or whatever holidays you had. All right, so we're going to go through and we're going to gather some other information here that we're going to need to complete our drainage information. So the first thing we're going to do, this is an SCS pond. We would need to go through and find out what soils we have and what hydraulic soil values we have. So our great friends at the USDA has put together a fantastic website. Go to, that's going to be websoilsurvey.sc.egov USDA gov, or you can just type in USDA soil survey. Select the green button there, and we can go through and I actually had one up earlier, just where I'd save us some time here. Calm down. Oh, wow, their government site's going crazy. All right, there we go. So like I said before, this job is in Mississippi and our good, lovely Gulf shores. Highly recommend some good fun times down there. This is in, so what we're going to do is wait a little bit here. Right. I talked up their site and now they don't want to load up for me. They're like, no, we're going to get a massive hit of people coming in, getting the soils information. All right, let's try. Anyway, download this. Oh boy, it must be running slow. Okay, well, we can skip that one. We can go to my next favorite site, which is NOAA Atlas 14. And here's where we're going to get all of our rain information for the site that we're in. And you can go to hdsc.nws.noaa.gov. And there's also comes up in a map and you zoom into the location of where your job is. I've already done that here and double clicked. And they provide precipitation depth and precipitation intensity. You're going to need to download both of these charts if you're doing pipe networks, and then you're going to need to download depth for your storm networks. With that, provides this lovely information here. I'm in depth, and I'm going to use my 24-hour event. So what I typically do is just go ahead and print that page out, save that into my hydraulic folder. Then we're going to go to intensity, and this one has our 5, 10, 15, 30, and 60-minute storms. I'm going to print that out, save that into my folder. Once all that's completed, let's say I also need some additional LiDAR information to make sure that my existing ground cover covers the entire area. Like we showed before in Civil 3D here, you know, my survey information is right through here, but you know, I've got an existing subdivision here that I also need to factor in that's going to be coming in. And so when I do my pre and post development maps, I'm going to need to make sure that I have that info. So I like to use, if you're fortunate enough to have your job at a coastal zone, you can come through here and then add that to your cart, draw a little area about what you want, go to your cart and have a little LiDAR, hit next, and then what type of output product you want. I want mine as contours. And here I'm going to just grab mine as shape files. And we're going to go back and I'm going to show you how to import that in with good old map import. So after you hit next, it'll prompt you for an email address and it'll send you a link on where you can download that information. So, oops, and you don't need to be rocking out like I do. So we're going to go back to our topography here. And I was actually already brought in that LiDAR, but I can show you how to do that as well. So we're just going to delete that out. And I'm going to delete that one too. All right. So first to bat, we're going to type in map import. And I've already extracted the zip file that they provided with us from NOAA as a AutoCAD shapefile here. And hit OK. And this one's already in the proper current coordinate system. If you needed to change those coordinate systems, right through here is where you would add that information. We can import polylines as closed polylines, and I'm not going to need to use any filters whatsoever. And there we go. Lay on. Oh, now I've got much more contour information. And these are also providing the elevations that I need. So I'm going to now create a surface here called LiDAR. And I'm actually just going to go ahead and turn that. Really don't even need that one on. I'm going to use that as no display. And I'm going to select all these guys, select similar, and add those to that LiDAR information. Either do that by contours or break lines. Just use mine as break lines. And I like to give mine a little description there for LiDAR. Takes a second there to process that. All right. Now with all of that LiDAR information in here, I'm just gonna cut that off for today. today's scenario, but I do have some pretty decent survey shots that have been provided to us, and that's in my EG surface. So we go ahead and show you how to merge both of those together. And I'm going to do this as a drainage surface. And that there. We're going to go in here, go to our definitions. I'm going to right click first, excuse me, on my LiDAR information, because I want that one to go down first onto the surface. And then I'm going to come back and I'm going to paste my existing ground surface on top of the LiDAR. And you see that where it's made those modifications and changes to blend those two together to create kind of a much larger overall surface, missing some information. Now, obviously LiDAR information is not as great as a survey, but for drainage here, we're going to make it work. So I'm going to go through, and now with that being the case, I'm going to save my topo information here. And I'm going to scroll down here to my data shortcuts and shortcut out that drainage surface for our benefit. Okay. And then now that that's done, I am done with that file. Okay, and go back to tool space on this one. And I'm going to go down here and bring in my drainage surface. I've got an overall existing one here. Now, I've gone through it. Last month, we were going through and applying catchments to our inlets here. And so I've gone ahead and done the same thing with this job and our drainage areas. And so it's going to be these catchment areas here. So this one's going to be what we're referring to as B2. It's got a C coefficient of 0.5, and that's about 6.4 acres. All of our proposed catchments through here, that one's B1 because that one's being added to this. And then our C series here, I got 0.33, 0.97, and where's my other one at 0.21, I believe. All right, and so all of that's draining through there. And so I can then copy this information, and then I've made some exhibits for my pre-development map. So this is going to be my pre-development drainage area. And then I've got a post-development map that I've just copied those catchments in into another file and labeled them up what they need to be. All of our C series here, C 2.1, threes, overland flow, and our B2 flowing into here. So now those are ready to go, and going to print those out and put those in our drainage report. That way people know what areas we're looking at. There we go. That one's going to be listed as EX01. So now we have both of those files taken care of. Now we're going to go through and we're going to see if our pipe design actually works, whether or not we need to upsize those pipes. So I'm going to go through and I'm going to select the Analyze tab. And the first tool we're going to be using here is Edit in Storm Sewers. And I just want my storm network. And we'll just put that one there as pipe network. And now all of our entire our 3 networks have been brought in with their proper outfalls going through here. Now, some of these I had mapped properly as curb inlets. This one right here, it didn't get mapped properly with our migration settings. Remember to go back and review last month's webinar on how to get that where it will actually come in properly. Change that to a great inlet. Hit OK. Oh, and what's on my inch grades? I must have a longitudinal slope. That's going to be 0.05. I don't really have a gutter there. That's actually going to be grass. So that's going to be 0.25. And in this particular case, because this is a great inlet out in the yard, I'm just going to do a 0.33 on each side for my gutter and road cross slope. And let's see if that works. There we go. Oh, that's still not the one that I want. I want a upgrade. Thank you. There we go. All right. And this is going to be a head wall because that's our, this is actually our inlet pipe from our pond. So we're going to actually be balancing both of these at the same time. And that's going to be a curb inlet. Once again, you wouldn't have to set this up if my migration settings were proper, but in this particular case, that was not the case. 2 foot, and that road I know is at 1%, and the Manning's coefficient of 0.3 for concrete. And same thing on this one. Go through and change it to a curb inlet. Offsite road cross slope 0.02%, because that's in foot to foot, not percent. Just keep that in mind. You'll get some crazy results if you put 2% in there, by the way. 2 feet there, and that's a 1%, 1 there. And we're going to go exit out of that. So now I've got those curves. This is actually a manhole. Okay. And that's going to be a manhole as well. So, okay. That's our overall plan view, and that's how we can edit that in plan view. You could also edit that over here as well by just going in and selecting right through here on the inlet type. Now, storm sewers or the storm sewers extension, make sure that you check the green check down here if you've made any changes, because if you don't, it will not save them when you flip to the other tab. Kind of important, causes a lot of frustration. All right, so in this case, our drainage areas that we created with our catchments comes in when we exported it out from Civil 3D. Here's a caveat. If you go ahead and run storm sewer analysis in Civil 3D, it will populate these known queues. You actually want to remove those known queues if you're calculating your queue based off of standard CIA, which is going to be your drainage area, runoff coefficient, and your time, or I'm sorry, intensity. So if you run your pipe designer in, not pipe designer, but your storm analysis in Civil 3D, it will populate these known queues. When you want to put in a known queue, for instance, I need to know this is going to be my outfall run for that pond that's right here. So I'm going to highlight this right through here. I actually want the known queue that's coming out of this pond, which I will get from our hydrographs here in a moment. So first off the bat, so I'm actually going to just really run this system, and this system is the information that I need at this moment. When we go back, it's also put in our invert elevation here, information, our pipe sizes that we have listed in Civil 3D. Our rim elevations from our structures are automatically filled out as well. Now, if you wanted this software to run and design your pipe sizes, then you could go through and then delete each one of these like so. and then hit OK, and it leaves the function for design available for you, meaning that the software now will run through and design those sizes for you. There's some settings in here and options under, I believe it's design codes, to go ahead and whether or not you need to omit 21-inch, 27 and 33s, because in reality, it's the pipe manufacturers really don't make these anymore. And if you got them, they would be more expensive than just buying a 36. So I just go ahead and omit those sizes there. If you have a minimum pipe size requirement in your area, like crossing pipes in this area are actually 15s or higher, then you would need to select that functionality there and then hit OK. And then I'm going to pull up my IDF curve. Now, this is where we went to NOAA Atlas 14 for, is we're going to go here and we're going to select, so we're going to go through here, and here's where we would put in that information from NOAA. So let's go back to NOAA here just to show you. That's going to need to be intensity because this is rational. So there's your 5 minute, 10 minute, 15, 2 year, 5, 10, 25, 50, and 100 year storm. So you're actually going to need to build your IDF curve from that information provided you in NOAA. So this one comes in 5, 15, 30, and 60 minute sections. I've gone ahead and made one, and I've actually made a few. And so we can go through, and that one's going to be in, oh, nope, gonna actually need to go to the project for that one. Let's just say this one. And client, nope, don't have it there either. Let's try here. 3D project, Shieldsboro, engineering, ports. There's my base St. Louis one. And so to edit this, you just go in and type, double click on it and type with the 2 year elevation for 5 minutes. And it just works as a standard chart. 2 year, 5 minute. In this case, this is up here, not down here. So now it updates. And so that 5 minutes, 7.79, roughly there. And I'm a little bit further south. So that's why that number changed. So once you're done with that, you can save these. So if you're doing a series of projects in the same location, it comes in real handy. Once that's done, just go ahead and exit out of that. And now that IDF curve is set. However, when you export in for your next job, it's going to come back as sample. So make sure that you apply your IDF curve before you start working, because if you don't, you're going to run into some issues. Alrighty, so now I'm going to do a preliminary run on this, and I'm going to use the analyze with design, and my pipes need to be designed for 20, I think those are 10 year in Mississippi. Now we have the option here to use the interactive feature. I am not, because I'm going to want to show you how it changes the line and run here. Now, as I run this one, it says inlet on grade longitudinal gutter slope must be greater than 0. So that's telling me that there's something wrong within my system that I need to check. That's going to be over here. And my longitudinal slope is right here. So because this curve is on grade and not in a sag position, if it's the low point of your system, you need to send it to a sag. Or if it's actually not, it's just one upstream to eliminate some spread, then you're going to need to apply whatever your road slope is here. So in this case, I actually know that it's 1%. Remember, this is taken care of in feet to feet. And that's 0.01 as well. And that one is on grade at 0.0 and 0.0. And B1, this is a mistype on my part. And I'm going to, at this point, I don't have a green check, meaning that all of those modifications have been accepted. Now let's run this and see what errors we get this time. All right, line 11 has no flow. cannot continue. Let's look at line 11. That's going to be this one right here. It's that head wall. At this point, I need to actually design that pond and see what that outfall is going to be. So we're going to leave this up because I need to get that known Q here to run the system. So we're going to go back to Civil 3D. We're going to come in, we're going to launch our hydrographs. This little blank thing here. And what type of storm are we going to use? Are we going to use an SCS storm, or are we going to use a rational storm? In this particular case, this area likes everything in rational. It doesn't matter if it's over 25 acres or not. So I'm just going to double click on this one, and I'm going to need some preliminary information. First, I'm going to need a pre-development drainage area. Pre-DB. Okay. And from, let's go back and open up my pre-development drainage area. And that one is 12.71 acres. So I could click on this, hit properties. I didn't actually use the catchment tools to draw this for all of those that know how to do that or watch last week's video or last month's video. So that's going to be 12.71. 12.71. And I'm going to use a runoff coefficient. Now, for some information on what a runoff coefficient is, they're nice enough to provide you with this little handy dandy magnifier that brings you to help. And so here you will choose what your area is. In our case, those are all single family, and I've got a fair amount of pavement. Now you'll hear the terms a weighted C, and a weighted C is going to be where you calculate your area on a percentage base of different types of C values, i.e. if half of your site is grass, then you could easily use something like a 0.3 or 0.2. And let's say that the majority or the other half is all concrete. Well, then we would use a 0.9 or a 0.95 for that. And because that's 50-50, if you have a 3-acre site, then 1.5 acres of concrete, 1.5 acres of grass, and then so that splits down the middle of 9.5 from 0.3, and so then you get 0.55. So in this case, I've already done a weighted C of 0.51, and the time of concentration is going to be 27 minutes on this one. Also, we have the option to compute that weighted C. So in here, we can come through and we can add in specifically those areas that I was just talking about before. In this case, let's say 6.61 of that is 0.9. And let's see here, do some quick little math on me because I just made that number up. 12.71 minus 6.61 is going to be 6.1. And that one's going to be 0.3. And so my weighted C there is actually 0.61. All right. And if you'd like to go through and view what type of chart that is, you hit results and it would provide you with your hydrographic chart. And I've got this set to be 2-year, 5-year, 10, 25, 50, and 100. So we can show each one of those storms all together, or we can choose individual storms and see when that time to peak and outflow is. So our pre-development at a 25-year event is going to be 49.35 CFS. Now there's something that I forgot to check, and that one has my IDF curve already set for it. So I am correct. So this is our pre-development storm. And so I'm going to right click this and drag this little storm with a little lightning bolt through it over here. Now I need some post-development storms. check and make sure that your hydrograph number has changed. Sometimes it doesn't. We're going to call this one C because that is all of the inlets that go down. Excuse me. Go down through there, and we can go through and go back to our drainage and sewer map here. And I'm just going to add these up manually: 0.33, 0.97, 0.44, 0.12. All right, so we got this one to be at a total of 2.64 acres. And I'm going to use a weighted C of 72. And that one I've already pre-calculated out with my percentages here. And because all of this is in a pipe network, my time of concentration is actually probably going to be lower than 5 minutes. So you have to use a minimum, and that's kind of across the board of 5. So I can then run that, and once again, I can see the results of that hydrograph. Or just exit out of there. Now let's see what else I have here. I've got some, let's just close out of that one. Go to our post-development map that I've already created. And so 30 projects. Plans, current. Source. Nope. Post-development map. All right. So I've got some overland flow here, and I've got that basin 2 area as well that's off-site. So we're gonna go through, and we're gonna add in our, sometimes this happens if you notice, like if it's been selected before and then you go to create a new one, it'll pop up. Make sure that this keeps going up and that you have a new one, because a lot of times it's a little finicky. So we're gonna call this one B, and those areas are 6.4, and I've got a runoff coefficient of 0.57 and a time of concentration of 10 minutes on that one for that overland. I'm going to exit out of that one and do another rational. We call this overland. VRLAND. And that one's going to be 3.67 acres, 0.79, and a time of concentration of 15 minutes. Now we can also use the TR55 method here, and it'll allow us to provide a TR55 worksheet. For those that don't know what a TR55 method is it's pretty much based into 3 segments: sheet flow, shallow concentrated flow, and channelized flow. So if you think of this is going to be a water droplet falling at the highest point of your drainage area. And so if it falls at the top of your drainage area, it's got a max flow length of 300 feet. But let's say that your drainage area is half an acre, and so the point from the top to the inlet or to the gutter is more than 300 feet. Let's say it's 1,200 feet. So what you would do is you would take 1,200 feet and then you minus your 300 feet. So then we'll put 300 here, and we're going to apply the land slope that is involved. Say it's 1%, and it will go ahead and calculate the 24-year rainfall information, and that's based off of the precipitation depth that you've applied with the IDF curve. And then we're going to choose a Manning's value for that, and so that's going to be overland flow grass or short grass if this is a subdivision and this is a lot for that. So we're going to choose 0.15. All right. Now I still have 900 feet left of what's referred to as shallow concentrated flow. And a good way to imagine this or view this is if you've been out in a big field during a rainstorm or right after a rainstorm, you can see where the water isn't quite, if it's flowing down through the channel, it's actually kind of coming up out of the grass a little bit and turned into like a small, not really a river, but just where you can see the water up above the ground. That comes after that 300 feet, because if the water drop falls and then it gathers up with its other water droplet friends, then it gets so much that it then starts ponding and running on top of itself. So then that's kind of a, a childlike example of to explain shallow concentrated flow, but we'll go with that. Our water course slope, in this case, let's say that it's also 1% or 1.5%. And then our surface description in this case is going to be unpaved. Now, if this is flowing into a gutter, we would need the gutter information here. So your cross-sectional area is going to be the depth of your gutter times the length of your gutter, divided by 2 if it's triangular. The wetted perimeter is going to be the length of your gutter. So if your gutter is 0.1 foot depth and 2 feet wide, so it's going to be 2.01. The channel slope is going to be your roadway slope if it's following it. So if your roadway is at 1%, then your channel slope is going to be at 1% as well. The Manning's coefficient, roughness coefficient on this one, they've got set 0.15. You could change that to 0.13 for concrete. And then how long that gutter length is. I'm going to assume in this scenario that this is flowing straight into my inlet or great inlet and not factor in channelized flow. So with this being the case, this is going to give me a sheet flow time of 27 minutes, a shallow flow time of 7.5 minutes, and a total time of concentration of 34.6 minutes. So, and with that, it's already put that information in there and stored it. I'm going to run that one. And now I have 3 proposed post-development hydrographs. Now I need to add all of those together to get a total site hydrograph. So I'm going to be adding the C, the B, and the 4. And then to select those, you just select and then hold down the control button and hit OK. And now it's going to provide those hydrographs A, B, and C, and then it averages those out. Now, when we select on our hydrographs, we can see here that with this scenario, I've got my C hydrograph here for the 2-year event, providing a CFS of 24.71. Our B hydrograph is producing 36.84, and our overland is at 16.13, and it's combining those together. And here it's going to show us where that inflow hydrograph information is coming from. Now, after that, we need to go ahead and get some information and create a pond to detain some of that water. Now, the quick way to do that is to go back here to our drainage, and I'm going to type in stage storage, or if you wanted to, you can also go through here and then select stage storage from here. I'm going to call this pond A, and then you give it your project number, 01 12 23. And I'm going to actually select and define that basin. And in this case, I'm going to select it from the surface contours. You could also select it from the polylines. So we're going to call this pond A. I'm going to define that pond by selecting that surface. All right. Interesting fun fact, this is based off of style. So in this case, we have a pond running from 18 to 25 in 1 foot increments. If this style was set to 2 foot contour increments, it would produce this in 2 foot segments. So keep that in mind. At this point, we can go ahead and insert this table kind of off here to the side. And I'm going to also save this table or create a report that's going to give me that information to put into hydrographs. Okay, and then now that that's done, that table is there. If you need to put that on your plans, it's available for your drainage plans, or you can put this on your post-development map too, to explain what's going on with your ponds. So with that information there, we're going to go back to our hydrographs, and here we're going to do this by contour information that we just got from our stage storage. So we're going to start that at 18, and that was 5142. So once we select our bottom of our pond elevation at 18, got a contour information of 5142. And then if you just select on these next things, it will fill these out for you. And then you can put in the contour areas for each one of those. So 62, 68, and then 7505. Oops, that would be weird. 8854, 10. Oops, fat finger in this. 304, 11, 846, 13, 453. 13, 453, and 15, 116. All right, so it's going to go through and it's going to calculate and tell us what each total storage is available here. I'm just going to hit done. And so now the pond itself has been put in, but it's going to need an outlet. Now that outlet in our case, if we go back to Civil 3D again, is going to be this 30-inch RCP. And I'm going to go ahead and set that. So for rise, that's going to be our outfall pipe. The span, because it's not an elliptical pipe, is also going to be 30-inch. I've got one pipe. My invert elevation here, I'm going to actually set at 18, which is the same elevation at the bottom of my pond. So this is going to be a completely dry pond. All right, and the length on this one is going to be 226 feet, and I ran that back at 0.5%. So I'm going to compute that. If you had a riser structure or an outlet control device other than just a pipe, here's where you could put that information in with B or C. So if you wanted to put 6-inch orifices and you wanted 4 of those, and you wanted to put those at, let's see, a foot above the invert elevation. I'll change that to 18. All right, and then just the width of the box or concrete structure, and then 0.05 is fine. Then now this box is going to have inlets to take in before it reaches this 30-inch, and so it will cause your pond to stage up a little more and give you those elevations. If you have a weir at the top of that box, here's where you would choose that. And then if you have an overflow for your pond, then you could go through and then select this and add that. In this case, this pond is pretty simple, of just a pipe. I'm actually going to delete all of these through here and delete. And then I am going to now go exit out of here. Oops. Pond A. All right. Oh, pond A. So all right. after all of that is taken care of, we have our pre-development, our post-development combined into one. Now we're going to, and our pond built. If you didn't select this tab to get to ponds and double click on it, then what you could also do is go over here and then select pond to get it to this location as well. Now we're going to route all of this post-development information in through our pond. So it's going to be pond A routing. And I'm going to run my total site through there into that new pond. Now, keep in mind, I said that this is going to be a dry pond. If you were running a wet pond and that was factored into the total size of your pond, here's where you would select your surface water elevation for that pond. In this case, this is a dry one, so we're going to run it. In this particular case, our pond is sized, and so it ran properly. And so right now we're kind of storing a fair amount in the 2-year. Our ponds down here need to be stored for 100-year, and its outfall at 15 minutes is going to be 30.9 for our 100-year event. Now keep in mind that when we sized our pipes, we sized those for 25. So the flow going into that pipe is going to be 26.91. At this point, our pond is designed and good. We're going to check here. We're going to see, all right, for our 2-year event, our pond outfall is at 26.91. Our pre-development is at 49.35. So we've significantly reduced our CFS. And then you'll need to check that for each one of your storms here, all the way up to what you're designing your pond for. So if you're designing it for a 100-year event, this pond actually will store our 100-year event and almost half of what pre-development is. Now, if you're in areas where you're running a 1% if your site is 1% of the total drainage area, then you're going to need to verify this information to make sure that you're not actually exceeding that. And I think that's in Virginia is where I ran into that, in which case you can use stream stats to get that overall drainage area from there. All right, so after our pond is done here, we're going to run some reports. I want a watershed lead and a little legend. I'm going to run that one and hit all. Those time of concentration worksheets that we created to get our TR55. We're going to have that. I want my pond report. If you needed to add the rainfall report from your IDF or precipitation curves, here's where you can do that. And then your table of contents. Warning on this one, your table of contents will always get sent to the back of the PDF that you're creating. And so you have to remember to move that up to the front when you do that. So I'm just going to preview that one. After I've run it, it's got my pretty little legend here and my pond information here, and each one of my hydrographic reports for each storm, my TR55 report for those drainage areas, and then it's also got my pond report information with my orifices, my tailwater information, how much water I'm actually storing, and how I can keep that. And then at the same time, this will run all the way to the maximum amount. And there's that table of contents that I was talking about. Here's that hydrographic rainfall report that was added to it. And here's our routing for our actually pond. So for our 100-year event, my max storage is going to be 20,219 cubic feet of water. My maximum elevation is coming up to 20.94. So really my pond is really, really oversized in the situation. So if we needed to, or we were trying to get more lots, or we can make this pond more shallower, we could do that in this particular case. After that, hit print, you'd be done. So we're going to go ahead and close out that one. And I did want to make note of 26.91 here as we go back to our other program, and that's going to be this one. And we're going to put in that known Q of 26.91. We're going to run that. And I'm on because I actually probably needed the 10-year event. Now, because these are all going in at a dry state, I'm going to start those elevations just at critical, which is slightly below running at, I believe it's 97% full, which is its maximum. All right, so now it's saying line 1, 7, 10, and 11 have no flow. Well, line 1 is an outfall. Line 7 is an outfall. Line 10 is a manhole, and that's not going to have any water coming into it anyway. And 11 has no flow, but it does have the known Q. And so it's gone through and sized those pipes for me there. I can check this in my results. We have a variety of options here. You're down in Florida. We can go through and then we can print out this report here. I actually like to go through and check my inlet information here, DOT, and then you can also create your own custom reports by going through and eliminating which information you want and don't want in through there. You can add additional ones as well and apply. That will save each time that you have this program. So in this case, here's my area down through up, good to go. All right, with that report being done, you can go ahead and since we only have 3 minutes left, I'm going to show you this. And then right through here, all of these fit in here. If they do not fit in here, what you need to do is go back and go to plan and minimize about twice, hit report, and then double check. And now your pipe report is taken care of there. If you need profile information to double check and see if everything is flowing properly. In this case, my HGL is below my ground, but not in my pipe. My HGL is going to be the red line. The dash line is going to be my EGL. And we can print that profile view. If we need to, we can go through and then do inlet spread calculations here. Select inlet. And then right through here, we have the 2D, 3D option. In this case, for my C2, I've got a spread of 8.77 feet and a gutter of 2. So that's, if you were running it, it needed to keep that under 80%. I may need to add a structure upstream. And you can also print those reports as well. Just by using the print function there, print those to PDFs, then apply all that to your report, and you would be good to go. All right, well, we were almost ran a little bit long, but I wanted to tackle all of those so that you could actually get a drainage report out if you needed to. Maybe a little hint here, if you want by popular demand, Civil 3D offers another program that's called full-blown storm and sanitary analysis, and it will allow you to run both of those at the same time, so you're not using two. So maybe a hint for part 3 in the future. Looking forward to seeing you guys next time, and I hope that you learned something. As always, make sure you contact ATG if you have any problems with your software or need to update your AutoCAD Civil 3D licenses or need in-house training. And I look forward to seeing you guys in the future. Have a great day. Bye-bye.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.